Okay, here we go. We're on section 4-6. We're going to perform operations with complex numbers. And to really the main thing that we're talking about here is one of the 5 most popular numbers in mathematics. And when we talk about the 5 most popular numbers in mathematics, we're talking about 1, 0, pi. Those are the 3 that you've already learned about. Today we're going to learn about I. And then the 5th one is E, and we're going to learn about that later on this year. An imaginary unit I is simply the square root of -1. When we talk about complex numbers, we're talking about things like 4 plus I, or 4 plus 2I. And I always works as if it were a variable until you square it or something. We're going to talk about that in a little bit. Imaginary number is just I. In complex conjugates, if I had the 4 plus 2I, the complex conjugate to that, remember we learned about conjugates in the last section, is 4 minus 2I. Okay? And if we multiply those things together, you'll find that that I ends up squaring out, and it helps you to get things from the denominator that are square roots. The complex plane, you're going to really like that. It's super simple. It's just like a coordinate plane, but this is my real numbers. And these over here are my imaginary numbers on my y-axis. So if I was graphing that 4 plus 2I, I would go 1, 2, 3, 4, up 1, 2. And that would be the location of 4 plus 2I right there. And we'll talk more about that in a little bit. Let's take a look. Let's take a look at our next vocab word here. If I can get my computer to cooperate with me and page down. I guess I can do this. The absolute value of a complex number. The absolute value of a complex number, if we're talking about something like 4 plus 6I, and I want to find the absolute value of that, what that would equal, if I take the absolute value, what that would equal is the square root of 4 squared plus 6 squared. And I'll talk about that more in a little bit. The square root of -3 is going to be I square roots of 3. Simply because it's the square root of -1 times the square root of 3. We can multiply those things together and get the square root of -3. And when we square that whole thing, that's where this thing comes into play. Move these out of the way here. You get I squared. See, I equals the square root of -1, but I squared equals the square root of -1 times the square root of -1. Those square roots kind of cancel each other out, and it's just -1 as an answer. And so when I do I squared, I get -1. When I do the square root of 3 squared, I get 3. The result is -3. This is I squared. If we take a look, let's take a look at example 1 here. I can show you how this works a little bit better. In example 1, the first thing I'm going to do to solve for x is subtract 15 from both sides, and I'm going to end up with 2x squared equals -50. All right. Then I divide each side by 2, and I get x squared equals -25. Well, when I square root both sides, when I square root that -25, I end up with the square root of -1 and the square root of 25, which is I times 5, or 5I is how we write that. Don't forget, just like we did a couple lessons ago, when you square root both sides, you can't just have 5I. You have to have the positive 5I, but also the -5I. I'm going to give you just a couple of minutes to work on question number 1 there. Go ahead and pause the video and work on that. All right. So hopefully what you did is you subtracted 13 on both sides. and you got 3x squared equals negative 36. And then you divided by 3. Well, look what happened when you divided by 3. You got x squared equals negative 12. When you square rooted that, the I is there right away. But I want to show you something inside of that 12. If you take 12 and you break it down into a factor tree, taking you back a few years, 2 times 6 and 2 times 3. See, we have a pair of 2's here. So when I do the square root of 12, I really have the square root of negative 1, the square root of 4, 2 times 2, and the square root of 3. Well, this becomes I, this becomes 2, and this is the square root of 3. So what I have for an answer is 2I square root of 3. I'm sure nobody came up with that, but that's how you would do that. Sums and differences of complex numbers. When you add or subtract them, it works just like if it was an x. So, you know, you're going to add or subtract their real parts and add or subtract their imaginative parts, and that's how you're going to get it. So the best thing to do is show you an example of that. Let me cruise on to the next page here and show you an example. So if I'm going to subtract these, I take the real parts, 6 and 4. 6 minus 4, that's 2. And then I take the imaginary parts, 3i minus negative I, so it's 3i plus I, or 3i plus 1i. 3 plus 1 is 4, so I end up with 2 plus 4i. And if I add them, it's the same way. So you treat it exactly like if it was an x, but when it's an I, when you square it, you get that negative 1. So just keep it just like it's an x, and you'll be fine. So 2 plus 7 is 9. 5 minus 2 is 3, just like that. All right. Let's go to this next page here. On this next page, we're multiplying. This gets a little bit more difficult. When you multiply these things, you have to use the FOIL method. Remember, we talked about that, and I put it on the website, a review of FOIL on that one lesson. So we do first, negative 10. Outsides, 2 and 2i here, plus 4i. Insides, minus 5i. And last, plus 2i squared. And I squared is negative 1, so that ends up being negative 2. So it's negative 10 minus 2, right? So you have negative 10, 4i minus 5i, minus I, plus negative 2, because I squared is negative 1. Negative 10 minus 2 is negative 12, minus 1i, or just I. Now, here's why I learned that, or why the important part of that. I have an I on the bottom of this fraction, and I cannot have an I on the bottom of a fraction because that is a square root. Remember, we talked about square roots not on the bottom of a fraction. So I have to multiply by the complex conjugate. The complex conjugate of 2 plus I is 2 minus I, top and bottom. And so what you're going to have on the top is first 12, outsides minus 6i, insides plus 8i, last minus 4i squared. And so that top ends up being negative 6 plus 8 is 2. 12, you see it's minus 4, but this is a negative 1, so it's going to be plus 4. 12 plus 4 is 16. And plus 2i. The top ends up being this. That's the easy part. Okay? The bottom part is the cool part. Watch this. It's kind of neat how this works. 2 plus I times, ooh, my handwriting is getting shaky, 2 minus I. When I do this, I get my first 4, my outsides minus 2i, my insides plus 2i, and my last, minus I squared. And I squared is negative 1, so that ends up being plus 1. But look what happens to these right here. They cancel out. right? So I have 4 plus 1, which is 5 for my answer. That's how I'd use those complex conjugates. All right. Why don't you guys take a minute and go ahead and do those problems, 2, 3, 4, and 5. Just give yourself maybe 5 minutes to work on them. Work on all the ones that you know first. Okay. 12 minus 16 is negative 4. Negative 2i minus 3i is negative 5i. Okay. Treat it just like an x. This one, whoop, whoop. Can I get a whoop, whoop? Negative 36i minus 20i squared. Well, 20i squared is negative 1 here, so that ends up being a positive 20 minus 36i. Pretty tough one. Give yourself a clap on the back, a pat on the back if you got that one right. This one, 4 minus 6, negative 2. 4i plus 3i, 7i. Not too bad. This one, that's the tough one. Got to multiply the top and the bottom by that 3 minus I, and go through that whole process that I just went through. And if you did all that correctly and you went through that whole process, you ended up with 2 minus 2i. I'm not going to work through that. I can work through that tomorrow, but kind of go back to that same thing. Let's take a look at this one. You guys are going to like this because it's pretty simple. 4 plus 3i. 1, 2, 3, 4. 1, 2, 3. There's that point right here. 4 plus 3i. The point negative 5 minus 4i. 1, 2, 3, 4, 5. Down 1, 2, 3, 4. It's located right there. So the real number, the imaginary number, and you plot it. Not too bad. Now that absolute value stuff that I talked about, I'm going to show you this down here, how to do the absolute value of 6 minus 8i. It's simply the square root of 6 squared plus negative 8 squared. Well, negative 8 squared is always going to be positive. 6 squared is 36. 8 squared is 64. If I add those two things together, I get 100. And the square root of 100 is 10. So the absolute value there was 10. Let me show you why that works or what it actually means. Remember, absolute value in the real world just means distance from 0? Well, absolute value here means distance from 0 also. It means distance from 0, 0, this point. So if you look, you got the distance here is 4. The distance here is 3. I want to know distance from 0 at an angle. So that's that whole a squared plus b squared equals c squared, or the square root of 3 squared plus 4 squared. And some of you guys right away are saying, oh, I was a really good geometry student. I know that that's 3, 4, 5 right there. And so it's distance from 0 at an angle. That's how you find the absolute value. So that's a good way to remember that. You guys go ahead and take a look at that last, those last little ones here. Give yourself 2 minutes to work on that. All right. So the first thing they ask you to do is find the absolute value. The absolute value of this thing is the square root of negative 4 squared. Well, the absolute value of that would be 4. And its distance from 0, negative 4i, would be 1, 2, 3, 4. 1, 2, 3, right here. Yeah, it's 4 away from 0. That makes sense. This one is at 2, 1, 2, 3i. 1, 2, 3. What's its distance away from 0? Well, I could do it the Pythagorean theorem way. 2 squared, really the square root of 2 squared plus 3 squared. 2 squared is 4, 3 squared is 9. 9 plus 4 is 13. I got the square root of 13. And if I do this one, I should get the square root of 10. All right, make sure you check out the website, and we'll see you tomorrow. Thanks, guys.